Okay, now we have done with the theory part. Now we will see a couple of questions. Okay, the question number one. So in a two-dimensional stress analysis, the state of stress at a point is shown below. If sigma is 120 megapascal, tau is 70 megapascal, find out sigma x and sigma y. Okay, so in this question, so what is given? A plane is given. A plane is given. So incline some angle theta. On this plane, what is the value of normal stress sigma and what is the value of shear stress tau? 70, normal stress 120. These two values are given. So we have to find what is the value of sigma x and sigma y. Okay, so right now we have completed the theory. So the sigma x, sigma y, tau xy and theta. This much will be the input. If we have given this many data, so I will be able to find normal stress and shear stress on any plane. So okay, again we have to remember the our sign convention. By deriving the equation, we have taken an inclined plane, the measured angle theta from the vertical. On this particular plane, we have taken the normal stress is tensile in nature and the shear stress direction is like this. So then we got some equation for this normal stress and the shear stress. So use this equation is in terms of your sigma x, sigma y, tau xy and theta. This equation is the same, okay, in terms of sine and cosine. So we have this equation. The here actually the just reverse. This many letters and given, we can find these things. The here it is just reverse. These two values are given, so we have to find these values. Okay, so let us see what is the given data. The tau xy is already given as 0, means the tau xy, the shear stress, the value, it is not given, there no values are given, so that means this tau xy is 0. So we have to find sigma x and sigma y. So we have to find the sigma x and sigma y only. Okay, so we can, from this given data, we can find out sine theta. The sine theta is, this is given as 3, qr is given as 3, pq is given as 4, so then pr will be 5. Sine theta will be equal to 3 by 5. And cos theta will be equal to 4 by 5. So from here we can, if you want, you can find out theta. So this will come 36.86 degree. So this is the value of theta for this triangle. Okay, so you should know this triangle because this is a very famous triangle, 3 4 5. So if you take an angle, it is opposite to this side 3, this value theta, this is 36.86. You can easily, and just take the sine inverse, you will get the value theta, but anyway you should know this. So now we can use the equations. We can use the equation for the sigma and tau to find out the value of sigma x and sigma y. Okay, the the direct procedure by using the equations is like this. You have it is your stress block. So here I have sigma y, here I have sigma x. So I know this angle, and on this plane there is some normal stress sigma, there is some shear stress tau. So on this, what is the equation for the normal stress? Sigma equal to sigma x plus sigma y 2 plus sigma x minus sigma y by 2 cos 2 theta plus tau xy sin 2 theta. So in this equation, as per the given data, we have sigma is plus 120 because the direction is same as your and direction which we have taken in the derivation. So it is equal to sigma x plus sigma y by 2 plus so this is your equation. This tau xy term will be completely 0 because it is given tau xy is 0. So this will be the equation. You can simplify this equation and you will get, can multiply these two to the left hand side. Okay, so this will be the final equation. 240 is equal to 1.28 sigma x. You can work out this, okay, plus 0.72 sigma y. So this is your equation number 1. So similarly we can write second equation, which is tau is equal to, what is your equation with a negative sign, sigma x minus sigma y by 2. So this negative sign already there in derivation, so it is equal to sine 2 theta plus tau xy cos 2 theta. So here just substitute theta is equal to 7d, theta equal to 7d. So minus of sigma x minus sigma y by 2 you can simplify this equation and you will get final equation is minus sigma x plus sigma y is equal to 145.84. This is equation 1 and this is equation 2. Okay, so now I have two equations and I have two unknowns, which is sigma x and sigma y. So you can solve these two equations and we will get the value is sigma x equal to 67.49 Newton per millimeter square and sigma y is 213.33 Newton per millimeter square. So this is your final answer. Let us check the given options. So the final answer is option B. So this is the direct method you can use to solve this question, but to solve this you should know these two equations. And also you should be able to solve these two equations in terms of two unknowns. Maybe you can make use of the calculator also, but this is not the only method to solve this question. You can also solve this equation by using simple equilibrium condition. You can solve the equation by using simple equilibrium condition. That means, so this is your given stress block. Okay, so here I have sigma y, here I have sigma x. So the tau xy is not given, that means it is equal to 0. On this plane I have normal stress, which is 120 megapascal, and also I have the shear stress on this plane. It is equal to 70, right? It is equal to 70 megapascal. So now, so this angle is theta. So from the given triangle we can write sin theta equal to 3 by 5, cos theta equal to 4 by 5. So if this angle is theta, and if I draw a horizontal line over here, so what will be this angle? This will be theta. And if this is theta, just draw a vertical line. This angle will be, this will be 90 minus theta. And if this angle 90 minus theta, then what will be the value of this angle? Okay, this angle also going to be theta. Okay, so now what you have to find out? You have to find what is the value of sigma x and what is the value of sigma y. But to find out the value of sigma x, you resolve all the force along the x direction equal to 0. So here I have sigma x and this side is pq. So due to this sigma x which is acting on this surface or this plane, there will be some force acting towards and the negative x direction. Suppose if I take your sign convention is positive x and it is negative x. If we are keeping this sign convention, so due to this sigma x, the force is sigma x into area of the plane, this pq into 1. Okay, the 1, why I'm taking the 1, it is actually the thickness of your stress element, because finally to get the force you have to multiply this stress term with area. So area means there will be some length of the side into thickness, because in the equilibrium equation you cannot keep the stress terms. The force only you can the force should balance. The force, to get the force you have to multiply this stress term into the area. To get area, we will take the stress element always like this. Suppose it is your stress element, so I will be considering something like this. So this is your actual stress element. So we can consider a unit thickness, and this is the thickness. This is the thickness of the stress element. Okay, you can see this is the thickness of the stress element. This thickness is nothing 1. Okay, so that is why I am taking this is 1. So PQ is the length of the side into 1 thickness. You will get the area. This it is the area of the that side. You multiply with sigma x, you will get the force acting in the negative direction. We are keeping a negative sign. And now if you look at this surface PR, I have a stress sigma. A component of stress is acting along this direction, which is sigma cos theta. So due to this stress acting on this surface, there will be some force, and that force is acting in the positive x direction. So that is sigma cos theta, that is where stress multiplied with PR into 1. So this will give you the force due to the stress sigma. So now I have the shear stress tau acting here. This will be having a vertical component here. This will be tau cos theta, and its sine component will be acting in this direction. So that will give you a force in the negative x direction. So that is tau sine theta multiplied with PR, the length of the inclined surface into thickness, and all these force should be equal to 0. That is your equilibrium equation. So now we can substitute minus sigma x is unknown into PQ is given as 4 plus, and this value of sigma is given as 120, multiply with cos theta is 4 by 5, minus the tau is given as 70, multiply with sin theta is given as 3 by 5 into 1 equal to 0. So if you solve this equation, we can get sigma x equal to 67.5 Newton per millimeter square. So this is nothing but the same answer as in the case of the previous method. This method will look simple because we are not using any equation. We are just resolving the force to write the equilibrium equations. By a simple concept, we can solve this value. Okay, so now we got the sigma x. Similarly, we can solve the value for sigma y also. So now we can solve for sigma y. So to solve sigma y, you write the equilibrium equations along y direction equal to 0. So I can take sigma y sigma Fi equal to 0. So I have the force PQR. Okay, this side is QR, it is PQ. So due to sigma Y, I am taking the sign convention. The downward force is a negative and the upward force is positive. So by using this sign convention, due to sigma Y, you will be getting a negative force which is equal to stress into area, that is QR into 1. And if you look at this surface here, I have a stress sigma. So this will be having a component sigma cos theta, and it will be having a vertical component which is sigma sin theta. So this will create a force in the upward direction, that is sigma sin theta into PR into 1. And due to this shear stress tau, so this angle is theta, so this will also will have a vertical component. So this tau will have a vertical component, this will be tau cos theta. So that will create a pole force, that is tau cos theta into PR into 1 is equal to 0. So if we can substitute everything, minus sigma Y into QR is given as 3, it is plus sigma into sin theta will be, this is theta, sin theta is 3 by 5 into PR is 5 unit plus tau is 70 and cos theta is 4 by 5 into PR is 5 equal to 0, and this value stress also you have to substitute, which is equal to 120. So you can simplify this equation to solve for sigma Y, and finally you will be getting sigma Y is equal to plus 213.3 Newton per millimeter square. So this is a tensile stress. So this is your final answer. You can see the options. We got the same answer as in the case of the previous method, and correct answer is option B.